I met a family with AT in a small village in the southern part of Israel. They had 10 kids, 4 of whom were affected with AT. The clinical picture of AT was so overwhelming, and it was clear that this is a huge human problem and huge problem in human biology. And so I decided to make AT the subject of my PhD thesis. In fact, it's almost 30 years now, and I've been working on AT ever since. This is the ataxia-telangiectasia laboratory at Tel Aviv University. Our lab is fully dedicated to understanding, investigating, and obtaining new ways to treat ataxia-telangiectasia. We believe that the way to find new treatment modalities for AT goes through understanding the disease. There are about 15 members in our team, and each one is responsible for investigating a different branch of the very complex ATM network. We have a mission to investigate a disease which is rare, and because of that it is included in a group of diseases called orphan diseases. For these patients, this doesn't make much difference. It's their disease, and it's bad, and it's devastating, and these patients and their families deserve to have our attention, same as patients with very frequent diseases.
When you see a child having this devastating disease, you immediately, your heart is open for him, and you imagine what would happen if you had such a child. What would you do for it?
AT represents a microcosm of many areas in medicine, which, if solved and understood, would reflect on many areas in biomedical research and clinical medicine, ranging from neurodegeneration to immunodeficiency, cancer predisposition, and other clinical features. We first turn to identifying the gene. Well, it might be tomorrow morning, a week from now, months from now, and maybe 10 years from now. And it happened 8 years after we started that quest. In 1995, in this lab, the AT gene was identified, and the road to identifying the protein was very short. About 3 years later, our lab, and in parallel the laboratory of Michael Castan in the United States, identified the activity of that protein, and we began to understand how the deficiency of a single protein can cause such a wide spectrum of clinical manifestations.
We work very hard, and this work sometimes, at the end of the day it could be a happy day if you find a new result and you get something. Sometimes, it takes years. The student here work for 6 or 7 years on the same project. Sometimes a small hint or a small clue can bring us a new breakthrough. It's not just the tubes and the buffer or the gel that we are working on. It's a gene. It's involved in severe disease, and the idea is to find something that can be helpful for all these children.
Our goals are understanding better the ATM protein, how it works, how it is activated by DNA damage, understanding most of the different aspects and branches of the ATM-mediated network, and then based on all this information, trying to find hopefully a drug that would allow doctors to slow down the progression of the disease, treat the patients better, and improve the quality of their life. Every day we learn something new. Every day we make little progress, but then we ask what's next. So if you want me to give you the bottom line of our feeling is, okay, we've got this data, but what's next?